easy to use.
Hey, Greg,
Yeah.
how many objects in the database?
Oh, it has a complete has a complete sky map, and the more you zoom in, I think it has all that messenger, all the NGCs, a lot of the ICs, and it even tells you like tonight's best. So it tells you, what the best objects is to image tonight. But I've zoomed in and I've even seen comets in there too. So they'll update the database. If there's a bright comet out, they'll update the database to include the comet. You could just go right to the comet. So this is really cool stuff. And it has a nice built-in light pollution filter. See, so
Did you
it's
compare
really
the
something.
individual, did you compare the individual frames to what you're seeing? I mean, do they look good?
Uh yeah, they do. And what it does is not all of them are aligned and stacked. It knows if something is not good, it doesn't align and stack it. Because I'll look 10 seconds and it didn't move. I'll look it didn't move. And then all of a sudden it added 10 more seconds, which means the last two frames weren't good enough. So they were rejected. But they save it in the database as FITS files. See, they're still
Yeah,
saved, but they're not aligned and stacked in real time. That's the thing.
the reason I was asking is I was flipping through some YouTube or something, and I didn't watch it, but it was about one of these smart telescopes. And the
Yeah.
question that it asked was, are the pictures real? And I think that comes out of the Samsung, where Samsung got caught using AI in the phone when you took a picture of the moon to generate a much better picture of the moon than was real, than it really was.
Really?
Oh
Oh,
yeah, they got
wow.
caught. So because somebody took an image of the size of the moon in frame and blurred it completely and then took a
Yeah.
picture of it, and
Wow.
suddenly it had craters and all the detail in it that wasn't there. I mean,
Oh, wow.
they got caught. So the question was, are some of these other systems like this
No,
cheating?
I don't think so.
Yeah.
This is not. And then Mike, what you were saying, um here's how the sky atlas looks. See, you can zoom in and zoom out, and then you say if you want that star, you just and it'll go right to that star. It's really it's really impressive,
Oh, so it gives you an atlas.
Yeah, it has a star atlas inside. Yeah.
See, the Unistellar doesn't do that. It gives you a list of
Yeah, it has
objects.
a whole star atlas, all the M objects. I'll bet all the NGCs are there. The more I zoom in, the more NGCs I see coming out. So that all 8,000 should be in there, and even the ICs too, and all that. So it's really something. I'll tell you. Yeah.
They
So,
do a
and
lot
they're
of,
always improving the software. And then first time I plugged it in, it had a firmware update. So it updates the firmware in the C Star itself, as well as the software that's on the iPad. So it does both, which is good, you know.
I
So
found it. It was Queeve the Lazy Geek, but
yeah,
I still can't tell just look without watching it whether the answer is yes or no. And it is the C Star. He has a video on YouTube that says ZWO C Star S50. Your
yeah.
questions answered. Does this smart telescope cheat? And I have not watched the video, so I don't know if he's going to say yes or no.
Yeah, no, there's no cheating. It's aligning and stacking what it sees. I don't think it's smart enough. And I remember Chris Go was saying, I do a lot of planetary, and he's saying that a lot of the new software like Photoshop and PixInsight and stuff is adding a lot of AI, artificial intelligence, and that's adding stuff to your image that isn't there. And he says, don't shut off all the AI because you're trying to do science here. You're trying to see what is actually on Jupiter, the cloud bands and all that. You don't want to add more detail that isn't there. You know what I mean? So
yeah, but
uh,
but AI is a very broad brush, and certainly there's software that can add detail using AI software, but when you talk about software that's in PixInsight, it's really just a neural network software. It's not creating anything or adding anything. And if it were, the database requirement to add detail to any deep sky object that you happen to be imaging would be gigantic. And it just technically wouldn't be possible without
Yeah.
But I think there's a gray area though between adding detail as in it has a database that it pulls what that part of the sky should look like. That's one thing. But like Blur Exterminator has been trained on image so that it can recognize blurred detail. And if you crank it too high, it is definitely adding detail that's not in people's images.
Right, but I think more in the sense that it's adding artifacts in the same way that you can crank traditional deconvolution too high.
Fair enough. Well,
and like any tool, it's up to the user to say this looks right or this doesn't look right. And
I mean, I guess that's a fair statement. I'm not sure it's fair to say it's the same as regular deconvolution, because
true. I mean,
I think the thing that it constructs is more like detail in a artifact, whereas deconvolution is stupid. It doesn't know it's dealing with a deep sky object.
Right.
Blur Exterminator does, and when you crank it up too high and it takes detail and thinks there's something there, it's going to create something that looks more like a dust lane or whatever.
Yes, possible. I had a problem with stars within Andromeda, and it was trying to resolve those stars into something connected, more like the worminess that you see in traditional deconvolution, because it wasn't really recognizing them as stars. If I changed the settings, reduce the sharpening, and I think it did stars first, then non-stellar second, or vice versa, that solved it. But it can go wrong for sure. And because it's AI, I mean, anything AI at this point should be looked at very closely and also followed very closely, because there is a giant gray area and potential, for it to do things that you don't want it to do.
But I think Blur Exterminator falls into a category that I might call accidental detail creation, whereas what Samsung got caught doing was purposeful. Because so many people took cell phone pictures of the moon, they cheated.
Yeah.
No,
and I think that's exactly right.
And I'm annoyed at Queeve here because he turned off transcription in this YouTube, so I can't actually see what he's saying. Apparently he's going to make you watch it.
Yeah.
But just because it goes on and on with other stuff, I'm assuming his conclusion is it is not fake.
But yeah, AI, that's a big topic.
But I honestly, I've seen a lot of the pictures that Alex shows from the Unistellars, and to me that Seastar, I kind of like those. I mean, I looked at that and it's like that's a normal astrophotography picture, where some of the Unistellar ones they have a unique signature to them. I don't know how to describe it, but you kind of, when you look at it, that's what it was.
He shot a whole bunch more in New Mexico on that Portal 1 site. And I don't think he's even had time to mess with them, but he was getting what he thought, and the people around him, he had 10 people at a time, were pretty darn good and fairly short images, but far superior to other things he's shot. So it'd be interesting to compare those.
Yeah.
Well, really,
and don't misunderstand what I'm saying. They are still impressive for what it does, for how automated it is and how quick it comes up. They're very impressive, but and it could be my aging memory, but when I think back to those and compare it to what he showed from the Seastar,
yeah, I know what you mean. Yeah,
it looked more natural, maybe.
Yeah.
Yeah.
Well, that's good. That's good. Yeah.
Well, and the other thing, Seastar storing the images that you can process yourself if you want to.
Right.
And by the way, I think it may just be the stars. The first thing I look at most images are the stars round and small. Mm-hmm. And if they're kind of oblong and and smeared a little bit and they don't look like they're in focus, You know, that's a quick reaction even before I see the nebula. And those look like nice round stars. And
Yeah, they are.
reasonably
The
sharp.
tracking's really nice.
And that would probably be the easiest thing for some sort of AI software
Yes.
to do, is just replace all the stars in your image and make your
Yes.
stars look great.
Right, or tighten them. I mean, maybe they've
Right.
stolen a copy of Blur Exterminator and are using it.
Well, and then Blur Exterminator does tighten your stars more than anything else I've
Yep.
seen, or more easily at least.
And that's
Is
what
that a
Blur
free
does. I mean,
program, that Blur Exterminator?
No, it's $99, I think.
Oh,
oh yeah,
well,
and
that's not bad.
it's kind of magic.
Yeah.
This is the, let's see if I can share the screen. This is the last one I did with the Unistellar. And you can see it's. And
Oh, you have one?
I turned up the gain a little bit. That's what they do to compensate. They have a gain. You can turn up the gain in the brightness. So you can see that was over an hour.
Is that M33?
Yeah, it's M33.
All right, let me download it.
Well, I overexposed it. You can see it's overexposed. You see the green and stuff in here.
So maybe the Unistellar is a little more like what you would see visually, and that new one is a little bit more like what you'd see after processing images.
Yeah,
This is the one, but this one has a really good mirror. And you have to collimate these a lot. You gotta, check out the collimation, or you don't. These stars aren't too bad. But anyway, stop that share. It's not like you guys, like Linwood takes, and Ray and you guys take, and Wayne, you guys spend a lot of time. Hey Fred, how you doing?
Pretty good, pretty good. We're finally got out of the heat wave down here. So I start getting exercise and walking. My cardiologist likes for me to walk 3 times a week, 40 minutes or so.
Hey, do you, the visual guys, know what we're talking about when we talk about like Blur Exterminator? Have you ever seen it?
No.
Would you like to? I thought it might be interesting.
Go ahead.
Yeah,
Give me 2 seconds to get my screen organized here. And I was putting up a quick image. Hang on. Here is and I've forgotten whether this is which way this is. So this is a 1-to-1 zoom. So this is very zoomed in. This is the larger image in mono of the monkey head. So preview 2 is down here. I'm going to take preview 2. This is zoomed in 1-to-1. So this is what it looks like if you zoom in. It's kind of noisy. Stars are round, a little bit bloated. If you run a mild version of this is the process. And I'm going to run it on these small previews just so it'll run fast enough that you'll see it. What it does is it takes the stars and does a PSF calculation of them, and then uses that to do the others. And so you can see it. I'm going to flip it back and forth as soon as I find the right button. Here it is. So what it did is all the stars got a little smaller. Yeah. And that's very similar to a regular deconvolution. But if you look back here in this detail, it kind of sharpened it up. Not and to me, this setting is what I think of as kind of normal. I don't think I'm really creating detail. Now, on the other hand, if you take this thing and run it up on both of them, oops, wrong button, wrong something. Why didn't it take that? Oh, 0.5, okay. I don't know why one of them is 0.5, and let's see. I'm just going to run all of these up to their max and do it again. And what you get now you get a lot sharper stars. Well, I was hoping I was going to get some real artifacts, and maybe I did. You know, this is probably now more of an artifact, more texture in here than is really in my image. If I go instead to the, whoops, sorry. This is to a more nebula-like stuff. I think here, I didn't have time to try to pick my image. There, you see how some of this is not in my image. It's just making that stuff up. And I see a lot of people sending around images like this now, as though they were real. So
Got an airplane flying in there?
I don't know what it is, but yeah, I mean, it overdoes it. And you can get, there's a, you know, an area where you can kind of convince yourself. I don't think I'm quite there yet. Let me back down on it a little bit more. And I'm probably still overbaked.
Now, one thing on that, Linwood, is
Yes, sir.
because there are so few stars, relatively speaking.
Yeah, it's probably not a good.
Well, not using the auto PSF, because it's measuring the PSF within very small tile of the image. And so in all of that nebulosity where you don't show any stars, it's using the PSF from stars in other parts of the image. So if you put in, you know, if you do not do auto, but put in, you know, your measured PSF, that tends to help. And that's the advice they give.
Yeah, I'm going to let it, it'll take it a little while, but I'm going to let it run the whole image. But this has really changed what people are doing with photography, because I think some people, and I try, and I, you know, try to slap myself and look at it the next day and say, did I really push it too far? Because there's a fine line here between sharpening your stars and pulling a little detail out that was there, but it was hard to see, and just manufacturing detail.
Yeah.
And you know, a lot of images people are sending around nowadays, they're just making this stuff up. It's kind of silly looking.
If you like, I did a time lapse video of an image being processed. And I can show that, and that does have Blurxo, a little bit more aggressive settings than you use.
Go ahead, Scott.
Yeah, I let it go.
Okay.
But I would say, certainly since I've been doing this, when he came out with that Blur Exterminator, it was like the biggest thing to hit astrophotography since I've been doing it by far.
Yeah, I would agree with that. Do you guys see this?
It's not running, but I see it. Well, okay, I guess it is running.
Running then. So I kind of break it up to different sections, but I'll pause it at the Blur Exterminator.
Oh, wow.
Right there. So if I go back, oops. So that's the effect I got. And you can see the stars shrink, but more detail, sharpening / creation.
The dust lanes came out.
Excuse me?
The dust lanes suddenly appeared.
I'll just let it run. When I use typically what you call the mask sharpening. So a little, almost more of an effect, unsharp mask, sorry, from that. So you can see more detail there. If you like, I'll just let. So that's a calibration effect, again, for the non-imagers. Start with HA. So this is a non-calibrated image. And then with calibration, you lose all of that, all the, you know, that noise.
So you could theoretically,
Blur X
are
right
you
there.
using ZWO too, Scott?
No, for a camera? What, when you say ZWO,
The camera.
no, I have a QHY camera.
So
Oh,
I'm
I
kind
didn't
of
know
curious on the formats, like, Greg was saying that it was in fits. What does it normally take? I never heard of that extension before.
Mine does fits as well. That's somewhat a depreciated format though at this point, XISF, at least according to it. I don't know, is XISF a PixInsight proprietary
Yes.
format?
Juan created it and he's promoting it as a replacement for FITS. FITS was actually developed, I believe, by NASA.
Yeah.
Right.
You know,
For Hubble.
it was one of the early ways to capture data, and it's really nothing more than a TIFF file with a wrapper around it with some predefined headers. So it's more about the metadata than it is the content of the file. The content of all of these are basically the same kind of image data. It's more about the metadata.
Wow, that's nice.
How
Yeah,
did
you
get that
guys are,
color in there? How did you get the color in there, Scott?
Well, I'll go back. So the first part is the luminance data.
Yeah,
Which think of that as sort of the carcass, I guess, or the
Right.
meat of it, of an image. Then just because this is the order that I do, the next part is was the hydrogen alpha filter, so I process that. Then typically, I get the stars taken care of. I separate the stars from the RGB data, process the stars separately, and then I'll show you the color section comes up in just a bit. And you had asked before, Tony, about colorizing our images, and really we're not doing anything different than what a regular DSLR would do. A DSLR sensor has color filters on top of the sensor, and so it's actually collecting data, red, green, blue data, and then putting it together itself. And so we're really doing the same thing in terms of our adding color to our images. We're just doing it more manually than a typical camera would. That's the red, green, blue integrations.
wow.
Add them together, you get that. Color calibrate, you get that. This is an auto stretch, which tends to desaturate an image. So, you then stretch the image here in a way that preserves the saturation. Knowing what the real saturation is anybody's guess, I would say. This is probably, I would say, oversaturated to some degree, at least. But we don't, not being able to see these objects ourselves, it's hard to judge, how blue are they really, how red are they, so that's always a big topic of discussion is, are we creating colors that not necessarily different than the colors that the object really is, but are we creating more vivid coloration than you would actually see?
Yeah.
Well, and almost by definition with narrowband we are.
Oh, for sure. Yeah.
That's a little
Right.
different.
Yeah.
Because, people look at the Hubble palettes and think, don't think about it very much, but Hubble has hydrogen alpha and sulfur mapped to, let me get it straight, to green and red respectively. And the problem is if you saw hydrogen alpha and sulfur with your eye, they're both deep red. They're not even really a different color to the human.
Right. And even when, like, I add hydrogen alpha, if I understand it correctly, I'm highlighting those hydrogen alpha, clouds in the galaxy, but in a way that you probably wouldn't see that deeper red color that I'm showing for those parts of the image.
Right.
Probably gets lost in the overall color signals that you see with but visually, even if you're up close. And You know, I mean, there's another question is how much of what we show in terms of color, in terms of dust lanes, you know, would you ever be able to see that no matter how close to a galaxy you are? And how much is, you know.
Can I have the screen back for 2 seconds?
Yep.
If you're done.
I'm done.
There you go.
This
Can
is
I-
the picture that I was thinking about. I've cut out the author's name, but it's posted publicly to show it off. And to me, this
That's
just
cool.
screams at me like, no, that's not what it looks like.
Yeah. I mean, you did see that, maybe not exactly that, but the same sort of thing even
Yep.
before Blur X. I mean, you know, you could over sharpen,
Right.
Yeah.
put a lot more contrast in. And there's another thing. Now we have a new stretch tool, GHS,
Right.
global hyper something stretch.
Generalized hyperbolic stretch.
Right, which more than any other stretch tool lets you place contrast. It gives you far more control over contrast throughout the image. And so we're able now to add contrast into an image, perhaps in ways that are not very real, but show things like dust lanes much more clearly.
Can everyone see my image a sec?
Yep.
I can.
This is the one I took yesterday with the Sea Star, 47 minutes. Look at that. That's M33.
I think that's great.
That's a fantastic picture. And the moon was not up, but I had two other things that were bad. One, it was windy as anything. Fortunately, I'm behind a fenced area in the house, and so it blocked a lot of the wind, but it was super windy. And the other thing is there's a jet stream above me right now, and usually there's not a jet stream above Florida. So the scene was actually pretty poor on this day, on
You
this
can
night
keep the jet
yesterday.
stream down
But
there.
look at that. As you zoom in, look at the fainter stars. They're nice and round. Look at that. See, even with all that wind. I mean, this is 47 minutes. This is a really nice shot. Can you see the other ones as I go through? Or not?
And it does all the processing for you automatically, so you don't.
Yeah. See, notice the time on the bottom. This is 31 minutes, 26, 26, 23 minutes. See it? 22. Can you see it on the bottom how it's changing? So this is, see, notice these aren't as good because only 11 minutes here, 6 minutes. See, so you got to really expose, and then I turn up the gain a little bit. That's why it's brighter. And then this is the 47-minute one. And that's it. So I'm really happy with that. Now you can take that and play around with it. Photoshop, make it look really good. But I mean, Scott and Linwood, you guys are really advanced astrophotographers. This is just a toy to you. But I mean, the people that aren't as into it, I mean, this is pretty damn good. You know, you have to
Money, yeah,
admit.
I agree.
Well,
And you know, to me, it's like woodworking. You know, I can go buy a table and probably spend
Yeah.
less money than any other way.
Yeah.
I could go to IKEA and get a table that I have to assemble, but not really build. Or I can go, you know, actually take raw lumber and build a table out of that and spend
Yeah.
3 times as much money as just any of the other methods.
Right.
But, you know, it's more about, you know, do you enjoy that process?
Oh, yeah.
Process, or, you know, you want just really
Yeah.
nice pictures.
And the nice thing I like about this is I do a lot of planetary imaging for Alpo and submit it to Association of Lunar and Planetary Observers. And while I'm, you know, and I do that right with the cameras and align and stack, and you know, and while I'm doing that, I just let this thing run. So before I start imaging the planets, I get a deep sky object, I let it run, and then I do my stuff with the planetary. So you can kind of do celestial multitasking. Yeah, you can do 2 things at once. That's what I'm calling it, celestial multitasking. You can do 2 things at once, you know. And then what I do as a rule of thumb too, is if you're gonna get one of these things, I would save an image every 5 minutes, because what happened is I noticed on one of my M13, I had a satellite go right through it. So if you did a half hour and then the satellite went through, you just lost a half hour's worth of data. But if you do it if you do it 5, 10, 15, 20, on number 25 isn't going to be too much different than 30. You didn't have the satellite, so you can just keep the 25-minute one. You know what I'm saying? So this way you have a sequence of them and you can see it building, and in case, satellites go through all the time. So you don't want just one image 30, you want at least 6 times 5, which will give you 30. You know what I mean? You want 6 5-minute images. So I do it that way, so that way
I think a
But,
lot
yeah.
depends on who your audience for them is too. I mean,
Right.
if you took that and then took an image that maybe Scott or I spent 30 hours photographing
Yeah.
the same object. No, wait. And
Yeah.
if I showed that to my wife, my ex-wife,
Yeah.
she wouldn't know the difference because she's looking at it on a cell phone and she's looking, oh yeah, it's a galaxy, and she'd move
Yeah.
on. If you're showing it to crowds of people that are just want to know what a galaxy looks like, they
Right.
both look like a galaxy. Now, if you're showing it to somebody who's interested in astronomy, who wants to
Yeah.
drill into it and look at the fine structure and see the stars, that's a different matter. But
Oh yeah.
your average person on the street isn't going to appreciate the difference between this image and one that takes 30 hours to accumulate.
Yeah, you got a point. Yeah, you're
I
absolutely
mean,
right.
they can probably tell the difference. I don't mean that.
Right.
I mean they're blind,
Yeah,
but they don't appreciate it. In other words,
right.
they wouldn't think it's worth all the extra effort.
And what's cool is this looks like a mini Hubble Space Telescope image of M33, whereas if you were to look at M33 through a 8-10 inch scope, it looks like a little fuzzy nothing.
Right.
You know what I mean? It doesn't excite people anymore.
But it seems like the perfect tool for any outreach program.
Yeah,
You offer,
exactly.
you have scopes available for visual observation, but at the same time, you have one of these running,
Right.
to show both more detail and to let more people look at it at one time, or,
Right.
visit with one person at a time,
Right.
on the
And then
scope.
they can download the picture. They can go get the C-Star app, and then just download the picture, while you're doing it too.
Yeah.
Sign into your Bluetooth account and they get the picture too. So it's amazing. Yeah.
Did you do any planets at all with this?
No, it really isn't for planets. I've seen the reviews. They're tiny. They're super tiny, the planets. It's only 250 millimeter focal length, so it's wide field. I mean, the 10-inch I have, the Meade LX200 GPS, I bought that in 2004, so that was when Meade was really good. And that's 2,500, and then you add a Barlow, you get like 5,000 millimeter focal length. But planetary, you really need focal length, so you need aperture and you need Barlows. So, and then that's when the atmosphere becomes more significant. Here, you're wide angle. So even though the seeing was poor on Jupiter, it was scintillating like crazy, that won't look that bad because it's such wide field. I mean, the full moon fits all in here. So you got over half a degree. Yeah, that's pretty wide field, So that's a nice thing about that.
I thought it was awesome.
Yeah, I'm gonna shoot. I'm gonna shoot this again when there's no wind and the jet stream's gone, and then there's no moon. Yeah, I would have gone longer, but the moon started rising and you could see it getting bright, so I just stopped at 47. But
There's
yeah,
really no
I'm really
reason.
happy with it. I'm really happy with this. I think anyone who's an amateur astronomer, I mean, my planetary cameras that I buy for are like $299 on average, and this was $399. So this was $100 more than I paid for my ZWO planetary camera. fast. You can't go wrong. That's what I love about it. And the money we spend on this stuff, 500 is not really that much, compared to right a cooled as is what 2,000-3,000, and then the mounts are the thousands, and the telescopes. I mean, your average deep sky setup's at least 10 grand, I figure, right? On average. And
Well,
then
we're
the
spending
software.
$100 just for a couple of adapters, that
Yeah,
are
that's what I'm
millimeter
saying.
thick.
It's like it's so. I mean, it's just so inexpensive. I love this thing. It's so
Now,
my wife calls it the little robot, the little alien. It looks like a
now,
little robot.
Gregory, this makes you a hero with a bunch of newbies. They just all of a
Oh
sudden.
yeah, they'll be blown away by it. Yeah, I'll guarantee it. Yeah.
Now you said something about you had talked to them about pre-production. So you had some interface with them before they went into production?
Yeah. It was a guy named Simon for ZWO, and what I did is I just they say contact us on their website. So I told them I purchased a ZWO and waiting for it to come in, and do you have this feature on it? And they would tell me no, they don't, or yes, they do. And I asked them, do you have a light pollution filter? Because most of us live in light, and they said yes, we do. And I asked them for the female threading on the where the lens is, and they said they won't do that. So it's not like they listen to everything you say. You know what I mean? But they did listen to a lot of what their customers were saying about it. So
Is the size of that opening such that you could thread it yourself and use existing filters? Is it like 2 inches or something that?
yeah, it's 2 inches, but they have an adapter online. Let me see. But on YouTube, Google, CCW. What's it? Lens adapter.
What I
Here it is. Here it is. It's this is the, let me share my screen a sec. I found it online. It's very easy. This thing right here. This thing. See, you can here's how the opening looks, and it just fits in. Can you see as it's changing? See, and that just fits in there. But there's no reason to add any other lens. It already has a light pollution filter. What would be good is to add like a diffraction grating here and get like spectra. That would be good.
Or like an HA filter or something to do some.
Or an HA. Yeah, you can you see it as it's changing?
Yeah.
Yeah, see, so notice there's no female threading there. I wish they did that. I don't know why they did, but for what, $19 that this thing costs,
Well, it's an extra $19 that they're getting. That's what they do.
Yeah.
Do you
Well, I don't
have
think
to do you have to do the Batnoff mask too? I see a Batnoff mask down at the bottom.
Yeah, yeah, they do have that. It has an autofocus feature, like once it aligns it, you press autofocus and it autofocuses perfect. There's no reason. You could manually override it. I don't know how to do that, but I've seen the autofocus is perfect every time. There's no reason to mess around with it. So that's just an extra thing you don't really need.
I'm kind of surprised that they didn't do an 80 millimeter for some reason. I don't know
Oh,
why.
here it is. This is what I've been looking for, because that's one thing that they need to do is like a lens cap for it. See, there's no lens cap, so this is gonna get all dusty, you know. Now they have it. Oh, that's good with the little flip. I gotta buy this. This is Etsy. Never bought anything from Etsy before, but I gotta
Huh.
save this. But yeah, so you can add filters if you want, you know, but that's more advanced stuff, you know,
Well,
like
with
an
an HA
HL.
filter, especially for nebulae, you'd
Yeah.
probably get a lot more detail. It'd be a black and white image, I guess.
But-
Well,
Oh, no, it's a color,
yeah, no, I'm sorry.
CMOS chip.
If you're able to shoot just the HA signal,
Just, yeah,
not
yeah.
the rest of it, then you could get really detailed images for nebulae.
Right.
But
But it's meant for, you know, the layperson. It's not meant for someone as advanced as you.
Right.
You know what I mean? So it's, but I'm just impressed with it because you know, I think it's a fantastic little thing. Oh, and it fits. See, there's very little room here between the things, so it's gotta fit perfectly. Oh, I like that. That's what I've been looking for. All right, after I get off of this, I'm buying it. Because you need
I'm
something.
surprised
I
they
wish
don't
they,
include a lens cap. That seems like a pretty
yeah,
basic.
they don't give you a lens cap. Yeah, exactly. And I don't think CWO makes this either. I think this is somebody
No,
else
that's
that made it.
printed by a guy who's printing that.
That's printed. Yeah, it's probably what do they call it? 3D printed. Yeah.
Yeah, 3D printing.
And that's what one of the ZWO representatives was saying. A lot of people are going to be 3D printing dust covers and lens holders and things like that. You know, he already knew that was coming. So, but other
That
than
was a
that,
great report, Greg. Thank you so much. Sorry you didn't do the chance to do the eclipse, but maybe you can do that again in a couple of weeks or so. I'm going to stop the recording here.
all right.